Hi viewers, this is Sri Ramulu. Today's topic is covalent crystals. So, what is a covalent crystal? A covalent crystal is formed when two similar or dissimilar atoms achieve stability by sharing valency electrons between themselves. Okay. In ionic bond, in ionic bond, transformation of electron will takes place. In covalent bond, sharing of electron will takes place. So that means in covalent bond, electron will share, but in ionic bond, electron transformation will take place. So that means one atom to another atom, an electron can transfer. But here what happens? One pair means two electron will be shared between two different atoms or same atoms. So one example is also given for same atom. Chlorine example. See here chlorine example. Last cell contain generally 7. Okay, so one single electron is there, so these three are paired electron. And next we take another same, see it is one atom, it is the same, both are same atom, similar atoms. It also has same one electrons, that is a unpaired electron. Then when these two things come nearer to other, then what happens, these two electron can be shared in between them, then they form a covalent bond by sharing. In this bond, electron in the valence shell of neighboring atoms are shared. Only neighboring atoms shared, but electron must present in valence shell. The crystals so formed are known as covalent crystals. So crystals, because of this covalent bond, are called covalent crystals. For example, we consider the formation of covalent bond in case of chlorine atoms. Okay, in the chlorine atom, how does it forms? Let me explain. Each chlorine atom has 7 valence electrons. Yes. Each atom shares one electron to form a pair, and the pair is shared by the two electrons. See what I explained just now. Each atom has one single electron, unpaired electron, and it is another atom has one unpaired electron. Then what happens, when these two are come near to each other, then these two electron will be shared between these two atoms. In this way, two chlorine atoms will have 8 electrons in their valence shell, and thus become chemically stable, means they cannot react with anything. Okay, what chlorine atom has 8 electrons. How it is 8 electrons? See here, now these two are, this having 7 electron and this having 7 electrons. Okay, and if you observe, when these two are nearer to each other, and when they share the electron, see around it 8 electrons are there, and next around it 8 electrons. So 1, sorry, 2, 4, 6, 8. Here also 2, 4, 6, 8. So that means this pair is sharing between these two things, these two atoms. That is why they forms covalent bond. Thus, the shared pair keeps the two atoms bound to form a molecule of chlorine. So it is now chlorine molecule. The crystals so found with the covalent bonds are called covalent crystals. Yes. Now characteristics. Covalent crystals are usually hard. They are very hard and brittle. Brittle means on them the small dust like dust will form. Okay, brittle materials with a high binding energy. See, their binding energy is very much high. They have high melting point and boiling point, like in ionic bond. Okay, in ionic bond also high melting point and high boiling point. They generally dissolve in non-polar solvent. So here covalent crystal can dissolve in non-polar solvent, ionic crystal can dissolve in polar solvent. Okay, they are dissolved in non-polar solvent. Non-polar solvent are benzene and carbon tetrachloride. I explained these things in the ionic bond also. Basically, all the covalent crystals are insulators. Why? Because no free electrons available, only paid electrons will available. That is why they do not conduct, because ordinarily no electrons are available for conduction. However, some are semiconductors like germanium. Among them few are germanium, means semiconductors. These crystals are transparent to long wavelength. Sorry, here it is long wavelength radiations, but opaque for shorter wavelength. Opaque means that they can act as a black body, means which they, for shorter wavelength we cannot see outside body, and for longer wavelength we can see the outside bodies. So friends, this is the covalent bond crystals. Don't forget sharing, watching and subscribing this video. Thank you.